Namaste children. Continuing with what we discussed yesterday, today we are going to see exercise 1.4. The first question has got about 9 to 10 fractions. So we have to find out without actually dividing whether they will have terminating decimal expansion or non-terminating decimal expansion. First, we have to find out whether they are terminating or non-terminating. Then the second part of the question is we have to actually divide and verify whether our results are right. So that is how the sum is given. Okay. Now, continuing with the principles that we saw in the last session, any fraction, first we have to simplify, and that should be expressed in the simplified form, number 1. Number 2 is, we have to do the prime factorization for the denominator. And in the prime factorization, we have to find out how many prime factors are there. If there are only 2 or 5 or 2 powers or 5 powers, it is terminating. If apart from 2 and 5, any other prime factor is there, it is non-terminating. Or only a prime factor which is not 2 and 5 is also non-terminating. Okay. Can I repeat once again? So in the prime factorization of the decimal, you should see the prime factors of the denominator. If the denominator has got prime factors 2 or 5 or 2 powers or 5 powers, it is terminating. If apart from that, if there is another prime factor, then it is non-terminating. Or it has got only some other prime factor apart from 2 and 5 or its powers, it is non-terminating. So this is the rule. Okay. Are you understanding? Now let us see. First we will take the first fraction, 3125. It is in the simplified form. Therefore we will take up the denominator. 3125. Obviously only 5 is the first prime factor. It doesn't have 2 and 3. So it is 6, 2, 5. Then again 5 it is 1 to 5. Then again 5 it is 2 and 5. Then again 5, only 5. So it has got only 5 as the factors, 1, 2, 3, 4, 5. So 3, 1, 2, 5 is obviously 5 power 5. Therefore this is terminating. So the first is, I'll just write here on top terminating, T for terminating. Correct? Now we'll move on to the second. Are they in the denominator, in the numerator? In the simplified form, there is no common factor. So the fraction is in the simplified form. So the denominator is 8. Let us prime factorize. Yes, you are right. It is nothing but 2 cube. So it is 2 cube. So only 2. Therefore this is also terminating. I'll write here. Next, we will move on to this. So this has got 455 in the denominator. Obviously, they are in the numerator and denominator cannot be cancelled by a common factor. So we have got 455 as the denominator, which we can simplify. It is obviously only 5. You should start with 91. It is 7. Now 13. So it is 1. Therefore, 455 is factorized as 7 into 13, all prime numbers except 5, or in addition to 5, we have got 7 and 13. Therefore, this is non-terminating. So, I will round it like this. And here also, continuing with the fourth sum, we have 15 by 1600. So, it is not in the simplified version. So, we have to simplify that. How do we do that? The common factor is obviously 5. So, cancel 3 5s are, and then here 3 5s are, then 2 5s are 320. Alright? Now let us factorize the denominator. So start with 2, 160, it is 80, 40, divide by 2, 20, divide by 2, then again you divide by 2, it is 5. Now check your answer. 2 once, 2 again, one more time, 2 again, 2 again. So what have we got? We have got 1, 2, 3, 4, 5, 6. So 320 is equal to 2 power 6 into 5. So it doesn't have any other factor. Therefore, it is terminating. Are you understanding? Now we'll go to the next. Fifth sum. Fifth sum, what happens? Here the denominator is 343. There is no common factors for both the numerator and the denominator. Therefore, carry on as it is. So 343, if you can factorize, this is 7 times, you will get 49, and then 7. So it is 343 is equal to 7 power 3. So what kind of decimal expansion you will come across? It is non-terminating. It is non-terminating. Okay. Are you understanding? Now next, go to the sixth one, is already in the simplified form. The factors are also given. It's only 2 power of 3 and 5 square. Therefore, only 2 and 5. Therefore, you can straight away write it as terminating decimal expansion. Clear? Are you getting it? Let us move on to the 7, 8, 9 and 10 sums. We'll move on to the seventh sum. Seventh sum, the denominator is already factorized. 2 square, 5 power 7 and 7 power 5. And obviously, we cannot cancel with any of these numbers, 2 or 5 or 7 with for the numerator. We cannot cancel 129 with any of these factors, 2 or 5 or 7. Okay. Therefore, we can conclude that this is non-terminating. Okay. Now, come to the eighth. It is given to be 6 by 15. So you can cancel by 3. It is 2 3s are and 5 3s are. Okay. If you don't cancel, what will you all do? You will start prime factorizing 15 and say 3 is there apart from 5. Therefore, it is non-terminating. But that can be cancelled. So that's why we have to first simplify and then factorize the denominator. Okay. Now 2 by 5, you all know it is only 5 for the denominator. Therefore, it is terminating. Now come to the ninth sum. It is again can be cancelled. The numerator and the denominator can be cancelled by means of 5. So it is 7 5s are and 10 5s are. Now tell me, this is nothing but 2 into 5. Therefore, only 2 and 5, that is terminating. Now what about the 10th sum? The 10th sum, look at the numbers. They are or they can be cancelled by means of 7. So if you cancel, you will get 11 7s are, and then this is 30. It is 11 by 30. Now we'll factorize 30. You will get, first is 15, then again 3, again 5, 1. Therefore, you will get 30 is equal to 2 into 3 into 5. Therefore, one 3 has come as an extra factor. Therefore, the 10th sum is non-terminating. I'll just write as NT. That's it. So, we have finished all the sums. Now, I'm going to give you a homework. You have to work out. Now, you have to find out the decimal value of each and every fraction, all the 10 fractions, and find out whether it is matching with your finding, whether they are terminating or not. Then only you will be able to verify that your conclusions are correct. Will you all do it as homework? We'll get back to the results in the next session. Thank you and wish you all the best.